Hello and good morning, everybody. Thank you for joining us today. Actually, it's afternoon. Thank you for being here, spending your lunch hour with us. Hopefully, this will be beneficial to everybody. Um, I'm going to start off today. We're going to talk about a multimeter. A lot of the people that are joining us today are here to get ready for either an in-house competition or maybe the TMC Super Tech, or just to help their multimeter knowledge as a whole. When we talk about a multimeter, it's multiple tools in one. It's not just a voltmeter, it's not just an ammeter, ohmmeter. It's all kinds of different pieces of equipment that can help diagnose things. And a lot of times says, why do I need to do this? I know how to use a multimeter. Well, a lot of guys are pretty good at this, or guys, girls. We have a very wide range of people in the field anymore. But I also think this is a very good refresher because no matter what about any part on a truck anymore, really requires you to know how to use a multimeter. That we've been very involved in a lot of state competitions and also Super Tech, and about the only station now that doesn't require use of a multimeter is tires. And I don't think we're too far off there with the advent of tire pressure monitoring systems. We'll have to use a voltmeter on tires now. But again, we're going to kind of go through this thing step by step. Hopefully people will get a little bit better understanding what a multimeter can do for you and some ways you can use it. One of the first things we talk about is whether you're using the meter we show in the screen, or you got your own, you got a shop one, you're at a tech event, you're going to grab a meter that you've never seen before. You always want to make sure that meter is ready to be used. So if you turn your meter on and you see a little battery indicator come on, this one kind of looks like a AA battery. It may look like a little car battery symbol, or on some meters it may actually come up and say BATT. What is that telling you? It says your internal battery is too low, and before you try to use it, what do you got to do? Replace it. One thing too is I always tell people, what do you do with a smoke alarm? You're supposed to replace your battery once a year. I always say the same thing about a multimeter. Another thing too is don't be cheap on a battery. Don't go down to the local dollar store and buy a very inexpensive 9-volt battery, because if that thing starts leaking acid, it is going to possibly ruin your meter. So put a good one in it and make sure you replace it once a year. But this meter is providing power from that 9-volt battery to do its tests, and if that battery is not good, you're not going to be able to do the test properly, or it's going to give you erroneous readings. So once we've done that, we want to check our leads. The easiest thing we can do is turn our meter to ohms and touch our two leads together. The meter should zero out. If it doesn't, it tells you either you got bad leads or you got a meter that's out of calibration. So if you look at the slide here, the one on the right zeroes out, the one on the left doesn't, and it lets us know that, hey, there is something wrong with that meter. We came up with a high-tech tool here, years ago. You all know it as a paper clip, but it's a way that you can take your two leads out of the meter, straighten out that paper clip, bend it in a U, and you can put it where those two meter leads go and check the meter itself. We've taken the leads out of the equation so we know, hey, my meter is good, or hey, my meter is what's defective. The nice thing about buying a quality meter is if they do get out of calibration, you can send them in and get them calibrated and make sure it's right. What do you do with a torque wrench once a year? You send them in and get them calibrated so you know you're using a calibrated, accurate piece of equipment. But again, go through, check it. If it zeroes out, hey, my meter is good, I can move on. If not, you got to send it in. You can't. Also, people tell me, well, I just subtract whatever the difference is. I'm not sure that's a real accurate way to do it. We can now go back and we check leads individually. We can take the black lead out, put leave the red one in, and use just the tip of the red lead to put it where the black lead should go, and we're going to check just that red lead. If it's bad, it tells you got to replace those leads. Take the red one out, do the same thing with the black lead. All we're trying to do is make sure that meter is right, not only the meter, but the leads, to get accurate readings. That a difference in a little bit of resistance with a defective lead could very easily cause you to replace a defective sensor, or check something inaccurately simply because it's picking up extra resistance. The other thing too is you got to make sure you understand your meter. That most meters that we talk about now are what's called auto ranging. And when we say that, that whenever you put that meter across a 12-volt battery or a 6-volt battery or whatever, it's going to automatically move the decimal to give you the most accurate results it can. That depending upon brand, it may say auto, may say manual, may say MAN, but we have to make sure we understand it, because auto range can be the most important thing you'll ever do. That meter is smarter than all of us put together, so let the auto range do what you're supposed to do. The one exception I found, if you're trying to check something like an ABS sensor dealing with a very, very low voltage, usually that's less than 2 volts, and it's usually an AC signal. To get a more accurate reading and a faster reading on that, sometimes it is handy to use the range button and put it down on the 2-volt scale. The thing you got to keep in mind is whenever you're done with that, turn the meter off and turn it back on, put it back on automatic ranging. If not, if you left that thing on a 2-volt AC signal or AC input and went over there and stuck in a wall outlet, what would your meter read? I'll let y'all think about that for a minute, but the meter should come up and give you an OL. It says out of limits, out of luck, whatever you want to say, but it doesn't mean there's nothing there. It's simply way above what you said that meter is going to see. You put it on a 2-volt scale, so it's looking for 2 volts or less. Anything above that, it's going to give you the OL. So you got to be careful that you are on the right range and understand, what that meter's telling you. But again, auto range is one of the handiest things because it's automatically going to go to it, especially when you get to the Ohmmeter function. If you got an old-fashioned manual range, that's a lot of knob changing, until you get the right scale for what you're trying to check. On the manual here, we had a question: are all leads the same? And I can see questions that are typed in as y'all put them in, so please feel free to type in any questions you do have. But we had one gentleman ask, are all leads the same? No. You definitely want to buy quality leads if you do have to buy replacements. There are some good, let's say, kind of generic names that are still very good leads. You want to make sure you do buy quality leads that do have the right ratings. And one of the biggest things is make sure they do have the right flexible wire on them. Otherwise, I've seen those be a lot more prone to breakage, and that's where you get a lot of your inaccurate readings, because the leads will actually break inside the insulation. So you do want to make sure you are using quality replacement leads if you do have to buy them. Again, on the slide we're showing right now is that manual versus automatic range. That some meters, again, we're going to talk some generalities right now, is that auto range icon did turn off, so you are on manual range now. So best thing I can tell you is to turn it back, turn the meter off, and turn it back on. Hold function, this is not something all meters have, but the hold function is very, very handy, that if you are trying to take a reading of something, and you'll notice through this PowerPoint that there is lots of times where I took a screenshot of the meter. I am not the most coordinated person, so can you imagine me trying to hold 2 meter leads and take a picture, or trying to compare a service manual or whatever? So the hold function allows you to put those meter leads across the battery, across resistance or resistor, and hit the hold button. It's going to freeze those results. So it can be very handy when you are trying to do some of these checks. So make sure you take advantage of it. They put it on there for a reason. Operation too. Again, we talk about make sure you understand your meter. There is differences. Anything electronic, you get what you pay for. Make sure you know what the range of the meter is capable of. Again, the one we're showing today on AC, you can go anywhere from 0 to 1,000 volts. What does that mean if you're trying to read something that's over 1,000 volts? Again, oh well, because you're beyond the range of it. Do not think that, oh, there's nothing there, and stick your finger there. They will find you there tomorrow. That, again, know what the meter is capable of. And it doesn't matter whether we're talking about voltage, we're talking about ohms, that if it's above what that meter is capable of reading, it's going to give you an OL that can throw you off. We're talking about the Ohmmeter section. I've seen a lot of meters that, again, somebody didn't want to spend a lot of money. wind up buying a economy type meter, and half the values they're trying to check on sensors, the meter doesn't have the capacity to even read it to do a fair check on. Same thing on DC. You know, again, this one's got the ability to go up to 1,000. I've seen some meters only go up to 400 volts, so again, can very well limit what you can and cannot check. So once we've kind of gone through our meter, we know we're ready, we know our meter's functioning properly, let's actually apply it to something. And the first thing we're going to talk about is a voltmeter. That one thing people think a voltmeter is a lot more high tech than it actually is. That if I've got a battery sitting here, that battery's at 12.5 volts, I'm going to put my red lead of my meter on positive, I'm going to put my black lead on the negative post. What does my red lead read? Answer is 12.5. What does my black lead read? Answer is 0. What is the difference between 12.5 and 0? Answer is 12.5. That's all that meters do, that voltmeter's telling you, is the difference between two different points. So I have 12.5 here, I have 0 here, difference is 12.5. Now I can take that same battery, grab me a couple of cables and a starter and hook it up, just like it would be on a truck. Doesn't matter where I put my positive lead right now. I put it on the starter. Nothing's happening right now. The truck's just sitting there, so we have no current flowing. And I put my black on the starter negative. What am I still going to read? 12.5 on this positive, 0 on the negative. The difference is still 12.5. As I said before, we can move these leads anywhere we want to. Positive's still going to be the same because, again, we have no voltage or no current flowing, so we have no voltage drop. So I can put the red on the starter or battery positive. I can put the black on the starter negative, the battery negative, the frame, whatever, and I'm still going to get 0, and the difference is 12.5. Now, if you look at the slide right now, that my meter's showing 12.5. Because again, the difference is between 12.5 of the positive and 0 of the negative. Excuse me. One thing about a voltmeter is people always want to use a voltmeter red on positive, black on negative. Well, one, if I put them backwards, what would it tell me? Same thing, it would just give me a negative number. Just as, hey, so you put your leads on backwards. But I saw 12.5 on the positive, 0 on the positive, so the difference would still be 12.5, but it'd give you negative. But right now, I've got them both hooked to positive. Got the red lead on battery positive, the black lead on starter positive. With no current flow, what does my red lead read? Still 12.5. My black lead at starter positive is also going to read 12.5. The difference is 0. There's no difference because we don't have any current flow, don't have any voltage drop. So that is the key to it right now, is making sure you understand, whether or not current's flowing. Now, if you look at this right now, if my meter were to display 12.5, what would that immediately tell me is wrong? Think about it for a second. But the only way my meter would display 12.5 would be if I was seeing what at the start, because we know we're going to see power here at the battery since we're right there. But if my meter were to display 12.5, what would I have to be reading at the starter positive? It'd have to be 0, and that would tell me immediately there's a break in that cable. Now, that's probably not ever going to happen on a big starter cable, but these same rules apply whether we're checking a blower motor or a horn relay or whatever, that we're only going to be reading the difference between those 2 points. So I would see 12.5 at the starter, and I would have to be seeing 0 at the starter, blower motor, whatever we're talking about. And it should immediately tell you there's a break in that conductor. Again, at a lot of tech events, we'll see somebody going through one of our boards or whatever, and they'll put their meter on there and they'll get that. And they're so used to thinking that, hey, I'm supposed to be seeing 12.5, they'll skip right over it. So stop and think, what should I really be seeing here with how I got my meter set up? If I can do it on positive, can I do it on negative? Answer is yes. I got my black lead at battery negative, what am I going to read? 0. Red lead at starter negative, what am I going to read? 0. Difference is still 0. There's no difference. Again, no current flow. Now we're going to change everything though. This is where everybody cares is let's have current flow. Let's crank this engine or energize the starter. So for simplicity, we're going to show you two different voltmeters right now. I got one across the battery and one across the starter. We'll look at the one across the battery first. My red lead reads 8.5. My black lead reads 0. So that tells me I have 8.5 across the battery. Obviously, we got a big load on, so we're not at 12.5 anymore. We've dropped all the way down to 8.5. So that tells what we have across the battery itself. I take my second meter and I go across the starter. My red lead reads 7.0. My black lead reads 0.3. What is the difference? 6.7. So that tells me between the battery and the starter, I've got a pretty healthy voltage drop. Where is it? And if you study this picture long enough, you can figure it out. But we got an easier way to do that. So I take my voltmeter, I go from positive to positive. Again, while that starter's cranking, I still got that 8.5 across the battery. I got 7 across the starter. Difference is 1.5. So that tells me I have a 1.5 volt drop on the positive cable by itself. Now, if you go back at the previous slide here and you stop and do the math, what's the difference between 8.5 and 7? Or 6.7 rather. Total is 1.8 volts. Now, if I look at what we did on the positive cable, we had a 1.8 volt drop total. I've got 1.5 in the positive, so what does that tell me I must have on the ground side? Kind of goes back to that algebra we took in school and we swore we'd never use. The basis is if you knew 2, you could always find the third one. Well, just like we did on the positive, we went negative to negative now. I had 0.3 at the battery. I had 0 at the starter. Difference is 0.3. That was a good way. We just double checked our math. We know all the tests were right. And if I was going to work on this truck, where would I start? Positive cable. I got 5 times as much voltage drop on the positive side as I do the negative side. What would be the first thing I would do to that cable? Take it off, clean it, wire brush it, make sure the stack up's good, everything's getting a good connection, and retest it. Now, this is very handy for showing you what we're doing, but is this an accurate test? Now, a lot of the guys registered, I know in your shops you use the more automated voltage drop test equipment, where it tells you to connect the large leads to the starter, small leads to the battery. You press start, it does a voltage drop test. That's exactly what that tester is doing, is what we're showing you here. While it's under load, it looks at all 4 points, does all the calculation, tell you if it's good or bad. The difference is when you use a piece of test equipment to do it, it does a fixed load and can do the calculations. With what we're showing you right now, it is not a good test because what don't we know? We have no idea how many amps that starter's pulling. You take a big heavy duty like a 39 MT or 42 MT starter, that thing can pull anywhere from 600 amps to well over 2,000. If you don't know what the load is, it is not a fair test. Because if you go back to TMC RP129, the spec for these tests, for the starter example, says you are allowed half a volt drop at 500 amps, which says if that starter was pulling 250, you would have half of the current, so you'd have half of the voltage drop. You'd only be allowed 2.5 tenths of a volt drop. So you have to know what the load is to be a fair test. Same thing if you're trying to do a voltage drop or a check on the power wire for your blower motor. So blower motor may pull 20 amps. Well, if you're trying to use a test light on it, does the test light put enough load on it to do a fair test to handle that circuit? No. So you have to do a accurate load comparable to what that circuit's being asked to do to make sure it's a fair test. But you do the same test on anything. Again, going back to TMC RP129, the same test applies to alternator cables. You're allowed half a volt at rated output of that alternator because what do those cables have to handle? So still very accurate test, but you have to understand what it's doing when it does those tests, and the same principles apply for any type of diagnostics. So when we talk about voltage drop, in order to have voltage drop, what do you have to have? You have to have current flow. If you don't have current flow, you can't have voltage drop. What does a voltmeter do? It only reads the voltage by telling you the difference between 2 different points. All right, next thing we're going to talk about is an ammeter. There's two different types. The first one we're going to talk about is a inline or a shunt type meter. This is made into your multimeter. Most brands of multimeters, that is a 10 amp. There are some that have a 20 amp. But before you use it, just like we talked about before about pre-checks, you want to make sure your amp meter is working properly. What generally happens is you loan your meter to one of your buddies. He tries to use it for the amp function, forgets to move his leads back, puts it across the battery, and you're out $12 to go buy a new fuse. So before you try to use it, you got to check that internal fuse. You can turn your meter on to ohms, take your red lead, and you're going to move it and put the tip of it where that 10 amp lead should go. If you get an OL, that tells you your internal fuse is blown. You're going to have to replace it. If you get a very low resistance, usually it's going to be right at 1 ohm or less, says that internal fuse is good. Depending upon multimeters, if you notice, we also have a milliamp function here. The circuitry of your meter may or may not allow you to do that, so you may have to open up your meter and actually check it. But some brands, it does allow you to check it externally like this as well. But again, if that fuse is blown, you're not going to be able to do the test. I'll show you what those fuses look like. The one on the right is the 10 amp fuse, or again, depending upon meter, it may be a 20 amp. The one on the left is a milliamp fuse. The one on the right can be $12 to $15 depending upon where you buy one. They're not cheap, so if you do something foolish, you're going to be spending money. If you do blow one of these things, I'll tell you, you do not replace it with a Wrigley's wrapper, a 22 shell, a glass fuse out of your old Ford pickup. These are special fuses. They are designed to blow quickly if they need to protect your meter. One of the biggest things people ask me though is, what would I use this for? And so we got that one truck. Every Monday morning it's got dead batteries. Well, kind of tells you it's one of two things. You either have a battery with a shorted cell and it's self-discharging and pulling the entire battery pack down, or you have some sort of a parasitic draw that's pulling those batteries down. And that may be a dome light staying on, a bunk light staying on, a relay staying engaged. Who knows what it is, but we got to figure it out. Is it truly a parasitic, or do we have other problems? In order to do that, we can use our inline amp meter, put it in line, and check and see, hey, this thing is pulling an amp or 2 amps or 5 amps, whatever it is. One of those things we want to do, though, is make sure we don't put our meter in harm's way and blow that fuse if we do have a fairly large load on. So, again, like our high-tech paperclip showed you before, we came up with another high-tech tool. Just a cheap fuse holder and put clips on both ends. And what we do is put that in line first. If it blows that 10 amp fuse, whoever you work for is more than happy to replace those. If you put your meter in line and blow it, that's kind of your baby. So, you want to make sure you do this step first. We always recommend doing it on the ground side. One of the reasons is it's much safer that if a ground cable, goes over and hits the frame, ground to ground, you're safe. Versus a positive cable flopping around there, that can lead to a thermal event very quickly. One thing you do have to remember, though, is unlike our drawing here, there's a lot more than one ground on a truck. So you want to take all the grounds off, bolt them together. This is, ECU, cab, whatever. You got to put all those grounds together so that we make sure we're pulling that current for the entire truck. If you miss a cable, it's going to throw all your readings off. So we put our 10 amp fuse holder in line first. And the question was, when would someone do this? Again, it's whenever you do have that truck that is staying on or killing batteries when it's parked extended periods of time. We can all go back to, the dead truck, and you ask the driver what he leave on, and his reply is always nothing. Then you find the refrigerator and everything else plugged in. But this is, that truck that, hey, we've unplugged the refrigerator, we've unplugged everything, and still anytime it sits more than, 2 days, we got dead batteries. So this is a very handy tool to check that to make sure we are making sure that, if it is some sort of defect or bad part or something on the truck, that we know we're addressing it. Once we put that fuse holder in line, though, we know it's under 10 amps because the fuse didn't blow. We can put our meter in line in parallel first. And the reason we want to do that is Anytime you disconnect battery cables and you reconnect them, you notice you always get a spark, especially when you reconnect them. Well, all electronics have capacitors in them. And whenever you disconnect them, those capacitors are going to slowly discharge. And whenever you reconnect the batteries, all those capacitors want to suck up all that charge and get charged back up again. So you'll see a very strong or very high inrush current. By putting your meter in parallel like this, you've not made, broke that circuit and reconnected it. So it's much safer and you're not going to get that spark. But you have to think about right now, that's the way I've got it connected in parallel with that fuse holder. What would my meter display if I had a 2.5 amp load on right now? I'll give you a second to think about it. And if you look at the meter displayed there, it kind of tells you the answer. Basically, it would be half. And the reason why is half that current's going to go through the fuse holder and half's going to go through my meter. So once I pull that fuse holder off, now it all has to go through my meter. I'm going to get a much more accurate reading of what the load truly is. I say that just to reinforce what I said before, that if you left a ground cable connected you didn't notice, again, you're not going to get an accurate reading because it's going to be going through that other cable that you didn't disconnect. So I'm looking at my meter right now. Everything's supposed to be off, and I still have a 2.5 amp load. Am I done? No, all I've done is confirm, hey, I do have a parasitic load on here. How am I going to find it? No magic answer. The only thing you can do is pop open the fuse panel and start pulling fuses one by one. You may go through and pull the HVAC. Nope, still there. I pull the courtesy lights. Nope, still there. Pull the dome lights, went away. Oh, it's silly. You left the door open. So make sure you understand what you are checking. And same thing too is you may have satellite systems or whatever that are booted up. So be aware of what you're trying to check, and also be aware how those different devices work. That if it is a satellite communication, whenever you reconnected battery, you probably woke it up. You're going to have to wait for a few minutes for it to go back into sleep mode to make sure you are getting an accurate reading of what devices are staying on. But it can be very handy to tell you, hey, we've got a 3 amp load on this truck. We got to figure out why. Otherwise, every time it's parked, we're going to have a road call. This was showing you the 400 milliamp function. Again, most meters have a 10 amp and then a milliamp. This particular meter has a 400 milliamp function. This allows you to really get a very, very accurate reading. But keep in mind, how many amps is 400 milliamps? That's only 4/10 of an amp. So if you have it hooked up like this and your buddy comes up and opens up the door and says, hey, what are you doing? I'm replacing my fuse. So we really don't recommend using this much for most technicians. One of the biggest reasons you really don't ever need to be that accurate, and it is so very easy to do something a little foolish and blow this fuse. But it is there if you do ever need to do something this accurate. But again, for the most part, most technicians never will use it. The 10 amp will do everything you need to do for parasitic type checks on the truck. The next type of meter we're going to talk about is a clip-on or an inductive amp meter. If you look at the drawing here on the screen right now, that shows a conductor. That if you imagine that cable goes from the battery to the starter, if you look at the way the current flows, we have what's called the right-hand rule of electricity. If you put your right hand on that cable and you put your thumb direction the current flows, look at the way your finger is going to wrap around that cable. Well, that's the way it's going to generate a magnetic field. A clip-on amp meter is going to register that magnetic field or magnetic flux, and it converts it into a number. So it's based on we see X amount of magnetic field being generated, you must have 37.5 amps going through this wire. Now, a couple things you got to be very careful about that. That whenever you go to use this meter, is if the jaws don't close all the way, it's not going to give you a fair reading. If you don't zero it out each time, if the meter is out of calibration, or a lot of the clip-on amp meters, especially the older ones, had what's called a thumb wheel. You put your thumb on it, you push in, you turn it left, and to calibrate it. What a cantankerous function on a meter. that you turn it one way and it jumps up to positive 10. You turn it back a little bit, jumps all the way negative 15. The modern ones now have a 0 button, so you can simply hit the button. The other thing is, again, talking about the way that magnetic field is generated. The clip-on ammeter has an arrow on it. You got to make sure you look at that. If you put that on the cable backwards, is it going to hurt the meter? No, it's simply going to give you a negative number. If you're trying to check an alternator and it says negative 150, that doesn't mean the alternator is sucking 150 amps. It means you simply put the tool on the cable the wrong direction. A couple other things you got to be careful about that too is if you have a positive cable going out, more likely you have a negative cable coming back right next to it. If you were to put that clip on around both cables, what's that going to give you? Basically kind of cancel out the magnetic field, and it'll probably give you close to a 0 reading. So do be careful if you are working with a cable that's mixed in a big harness. Try to pull that one cable away from everything else so you're not picking up that magnetic field from other circuits. Again, talk about ammeter. Ammeter only measures current flow. Has nothing to do with voltage, nothing to do with resistance, simply tells you how much current flows. Kind of like your water meter at your house. Is how do they send you a bill? They tell you how many gallons went through that water meter, and you get to pay for that. Next thing we're going to talk about is the ohmmeter. This one that every technician uses on a regular basis, but we found a lot of times people don't always understand really what that ohmmeter tells them. So I'm going to give you a little bit of a quiz here. That you're looking at a service manual. It tells you, hey, you're going to check the XYZ sensor. The XYZ sensor should be at least 6K. You put your meter across it, this is the reading you get. Is that sensor good or bad? Again, I know we got people in classroom type environment today. Feel free to discuss this with each other, but I'll give you the answer in a second. But again, the service manual says it should be at least 6K to be considered good. Based on what your meter says right now, is that sensor good or bad? The answer is, it's good. First off is how many ohms is 6K? That would be 6,000. If you look at what your meter is displaying right now, instead of a K, I've got this M here. What does M stand for? Mega ohms, or it is 10 to the 6th power. So that is not 5.46 ohms. That is 5,460,000 ohms. Is that more than 6K? Yes. That a lot of times those service manuals, all they're asking for is some sort of what they consider an infinite reading or an open. So as long as it's at least 6,000 ohms, we consider that open and it's good. Well, we're way above that, doesn't matter. Again, it's just that's what they're looking for an open. But if you didn't understand what that meter just told you, could you very easily replace a perfectly good sensor because you didn't understand? Yes, and it does happen all the time. We got 9 more of these. We'll go through them fairly quickly, but we got this one here. We got a 99.0K. How many ohms is that? Well, instead of the M, the K, that tells us that is 10 to the 3rd power. So you just move your decimal over 3 places. So that is 99,000 ohms. And just a fair warning, a lot of you guys know me from different tech events and ones coming up, is if you ever take one of my tests, you have to write the answer all the way out, because when my son was 10 years old, he could write this down, whatever the meter said. Did he have a clue what it meant? No, so you have to write it all the way out. This is another one on the M scale, 9.58. How many ohms is that? 9,580,000 ohms. Again, M means 10 to the 6th power. This one, we got 0.990 M. So at a quick glance, that tells you that must be just under 1 million ohms. Now, I'm a stickler. I make everybody write it out, but at the same time, too, I will let you round one, because if you told me that's 1 million ohms, obviously you understand what that meter's telling you. 9.76K, 9,760. And also, too, in the resources that Celia pointed out when we started this, there is a meter cheat sheet that you can download and print off, too. I'll show you that here in a slide coming up. This one, 21.71, again K scale, 21,710 ohms. This is one that messes with a lot of people. You got a 0.546 K. How many ohms is that? A lot of times people try to move it way too far. Most meters, if it's over 500 ohms, automatically put it on the K scale. But actually the meter could have displayed 546 ohms. Three more for you. 14.85 K. Move over 3, 14,850. The more you see this, it gets a lot easier, obviously. So I'm going to scroll through these a little faster. 0.983 K, just under 1,000. The last one here, 3.239. So just 3,293 ohms. Alrighty, now we got a little bit better understanding of an ohmmeter, what it's telling us. How do we apply that? And one thing is, guys tell me is that, hey, I went out and used that ohmmeter you told me about the other day. I checked the blower motor on the wife's car. Cool. What was it? 200 ohms? What's it supposed to be? I don't know. Well, if you don't know, does it do any good? Well, yes and no. I'm going to show you a couple of things here that gives you a little bit better understanding of that and how it can still help you, but also a way to properly troubleshoot things. Right now, we show a 5-pin relay. Every truck's got a ton of these things. How does everybody replace them? Or how does everybody test them right now? Well, generally they replace them. Or they take the one that's right next to it they know is good. Hey, horn works. Must be good horn relay, so let's just swap places. But as trucks have gotten a lot more high-tech now, relays, are just as important as any other component. We have to properly test them. The first time most of us ever used a relay is we got a set of off-road lights at the parts store for our old truck. And in that box of 2 fog lights or driving lights was a relay and a toggle switch. Most people threw the relay away because they didn't know, how to wire it up or didn't care or whatever. But that simple toggle switch is what activated the relay. Now what controls relays? We got body controllers, we got HVAC modules, some sort of a computer controls that relay. And it's a lot more important that we understand what that relay is doing and how it works to make sure it works right in the whole system. So the first thing we can do with a relay is we can check the coil. We're going to put our meter at ohms. We're going to put our 2 leads across the coil, check it. This one comes out and says that coil has a resistance of 102 ohms. Is that good or bad? The only way you know is you got to go to the manufacturer's spec sheet and says, hey, that particular model relay, it should be between 100 and 105 ohms. This one's right where it's supposed to be, so we know it's good. But what does that equate to? We're going to use the Ohm's law we talked about and take the voltage and divide it by the resistance. And that'll tell us what that coil should pull. So we take 12.5 volts, divide it by 102 ohms, says that relay coil should pull 0.12 amps, which is right where it should be. And that's where it goes back to, you can check things, checking that blower motor. If you did the math and says, ooh, based on this, that blower motor is going to pull 150 amps, that's probably not the right resistance. Or go the other direction, says the blower motor is only going to pull 2 amps, that's probably not the right resistance either. So it does at least give you a way to check it. Does that seem correct? I'm going to grab another relay here. Check this one. I go over the 2 sides of the coil. This one shows OL. What does that mean is wrong with it? So somewhere in that coil, there is a break. I don't know if you've ever taken a relay apart, but there is a small iron or steel center, and it's got hundreds of loops of very, very fine copper wire going around it. I have no idea how many loops there is. I tried counting, got bored, so I'm going to say there's 400. But somewhere in those 400 loops of wire, there is a break, so that is open, and that relay coil cannot work. This also goes back to make sure you got your meter set on the right setting. If you had this thing, say, turned on the 200 ohm scale or 2 ohm scale or whatever, and you had it on the wrong one, and it didn't allow it to go up high enough, could you, easily condemn a perfectly good relay? Yes. So again, make sure you do have your meter on the right function and the right scale. Next thing we're going to check here is we got one with a much lower resistance than it should have. Now, we said before it should be between 100 and 105. This one's only at 54. So what does that immediately tell you is wrong with that coil? Somewhere in those 400 loops of wire, we have 2 loops that are touching. That's the only way that would happen. And does it matter where? No, but since we basically have half the resistance that we should, that pretty well tells you in that 400 loops of wire, somewhere around loop 200 is where they are touching. So you're only going through half as much wire as you should. Does this relay still click and still work? Yeah. So what's the problem? Well, if you look again using Ohm's law, we're still going to use the 12.5 volts, but now we're going to divide it by the 54.2 ohms instead of the 102. Look what that did to our current. That's almost twice the current. Now, if an HVAC or a SAM module, whatever's controlling this, what's that going to do to that module? Depending upon how it's made, it may damage the module, or the module may shut down to protect itself. Says, hey, this relay is pulling a lot more current than I was ever designed to handle, so it shuts it down. This may be the HVAC system, this may be the radio, and this may be daylight running lights, whatever, but it's going to shut down to protect itself, and the end result is whatever that device is not going to work. What's wrong with it? Actually, it's a $3 relay. If you don't understand why it's doing this, could you spend a lot of time and effort replacing other parts? Yes, you could. So, very handy to understand what this relay is doing and why it's important to check these things. It's not simply, swap with one next to it or just put one in and everything's fine. The other thing we can do with a relay is we can check the contacts. And then if it's a 5-pin relay, it means it has a set of normally closed contacts and a set of normally open contacts. We're going to first check the normally closed contacts. So we're going to put our meter from the common to the normally closed, and we should get a very low resistance reading saying those contacts are closed. We can take our meter and go from the common to the normally open, and we should get an OL saying those contacts are open. Now, if you want to go even further on this, what could you do? You could energize it and make sure the normally open have become closed, and the normally closed have become open. One thing you still got to keep in mind, though, about a relay is 95% of the time when relays are switching, they are switching a live circuit, which means what? Every time they make and break contact, they are going to arc those contacts out. So if you wanted to go one step further in this, you could put this relay back in service. Again, we're going to use the blower motor as an example, but we want to turn that blower motor on high, have the load across it, and we can use our voltmeter like we showed you at first, and look at the voltage drop across those contacts. And if you've got a big drop across those contacts, that tells you, hey, those contacts must be pitted, burned, arced, whatever. And that's going to generate a lot more heat and impact that device further down. So there's many times that voltage drop can really help you diagnose something. So what's an ohmmeter do? It simply measures resistance. And you have to understand what that meter tells you. Is it a straight reading? Is it a kilo ohm reading? Is it a mega ohm reading? And this is one of the ones that tell you that you got to be careful of what kind of meter you buy. That I've had technicians that couldn't test anything because their meter only had a capacity of 4,000 ohms. So even that first example for that sensor, anything it did is going to show OL because it doesn't have the capacity to even read up to the 6,000. So you do have to be careful what you are using, and is it a quality meter to do it. Next thing we're going to talk about is a diode check. A lot of times people don't really check a diode anymore. It's all part of a module, but there are times it still is in service manuals that you have to understand what a diode is and how to properly check it. But first off, what is a diode? Well, basic description is it's a one-way check valve. It only lets current flow one direction. It doesn't flow the other direction. Depending upon meter, diode check a lot of times is on a shared function or a shared knob setting. So you have to make sure you do have your meter set up properly. And if you look on the screen here at the top, it gives you a little diode symbol. That whenever you put it on this function here with the knob, you may have to use your mode button and toggle through to make sure you are on diode check. That you don't want to be trying to use ohmmeter or continuity check or anything else. Make sure you are truly on diode check. Once you've done it, grab your diode, you're going to check it. The one we have an example here is actually a big, like a Greyhound bus alternator. Makes it for a much easier picture, but the way the meter leads are on it right now, current will not flow that direction. It's not designed to. And if I swap my two leads around, current is supposed to flow that direction. My meter will give a little chirp and it's going to display numbers. What those numbers actually are is the voltage drop across those diodes. That all diodes create voltage drops, so they can be handy if you're trying to design the circuit, but you also have to be very careful that they do create voltage drop in that line. Now, most diodes are going to check between 0.3 and 0.6 volts. You can buy different types of diodes. They're going to have less resistance across them, but that is an inherent nature, and they're all going to have some. So that one does pass. We're going to go to another one. This one doesn't matter which way I put my leads, I get an OL saying that that diode is open. It will not let current flow either direction. Next one we're going to talk about is a shorted diode. That I can put my leads on one direction or the other. I don't get any numbers on the screen. I get all zeros and I get continuous beep. It tells me that diode is shorted and is allowing current to flow either direction. Also on the diode check, we have the continuity check. And that continuity check can be a wonderful function on a meter. It can also get you in a lot of trouble. That if you look here, we have a piece of 10 gauge wire. Every single strand is broke but one. Will it show continuity? And the answer is yes. Can that wire handle any current? No. Same thing too is if I take that same piece of wire and instead of cutting it like I did, but I take it and I stab it once with a test light and I let it go on the bottom of the trailer for a year, and it gets full of green gunk and corrosion, what is the end result? It's got about the same capacity that wire does. So whether it's broken like we did for this picture, or if it's severely corroded, it will still show continuity, but it does not have the ability to handle any current. So you got to be careful. The continuity is just telling you, hey, it is connected from point A to point B. Does not mean that wire is of any quality. The other thing you got to be very careful with continuity check is electricity's lazy. If it can find a way back, it very easily will. I see a lot of times people will use a continuity function when they're checking out a trailer. If you look at a trailer, left and right turn are two totally different circuits, right? If I put my meter with, set on continuity and I go between the yellow and green circuits on a trailer, is it going to show continuity? Yes, it will, because it can go through the filaments of the bulb. Anytime you have any type of a coil, same thing will happen. That if you go from positive on a solenoid or a mag switch and go to ground, will it show continuity? Yes. Does that mean that solenoid is grounded? No. It simply went through the coil back to ground. Same thing with AC clutch, starter solenoid, relay, any of those things. You do have to be aware of, how is this thing wired? How does this current flow? So that I don't, waste a lot of time trying to troubleshoot something that's, that I think is defective when it's actually not. So if you are trying to check things like that, pull the relay out, disconnect one side of the solenoid, pull the bulbs out of the trailer. So again, we eliminate that redundant path that can get us in trouble. Here's that meter reference sheet we showed you before. You can access this on our website, or it's on one of the reference sheets here at the bottom. And one thing I did want to tell everybody for joining the webinar today, we do are offering a sale price on our meter kit if you'd like to take part of it. Just use webinar as a promo code, and we can set you up with our multimeter, clip-on amp meter, and temp gun for a special price of $189.99. One other thing I'd like to bring up to everybody is when we sent out a lot of the emails, we had a lot of feedback. People say, hey, we don't get your emails anymore. There has been a lot of laws changed on how we can send out emails, so we had to clean a lot of our lists up. If you're not getting these invites for these webinars, make sure you go back to our website and re-sign up. Now, we are going to try to do these on a regular basis, and one of the parts of the survey that Celia mentioned before was what other training would you be interested in. So please make sure you stick around and fill out that survey. That we do want to do these and support our customers. We appreciate you and want to make sure we're doing things to help you. So please sign up for the newsletters and also fill out that survey. I'm going to turn it over if anyone has any other questions, things I didn't cover. A lot of talking today and no water to keep me appeased while I did all the talking. But if you have any questions, anything you'd like to submit right now, we do have a few minutes more. And I think for the most part, they've been answering questions as they came up. So I do have a question here. One question is, my meter's about 20 years old. It's, I ain't going to mention brand. It works well. Is there a time you should upgrade the meter? As long as it works good, you're comfortable with it. I'm not going to tell you just to replace it. I would say that I would make sure you send it in and make sure it truly is in calibration. The only one I would really say is that if it's an old manual type meter, a automatic ranging meter is well worth the investment. It can save you a lot of time and headache. But, as long as it is in calibration, I'm not ever going to tell you to go spend money and go do another one. How can I accurately voltage drop test a 42-foot gap? Same rules apply. That you can use your meter, make you some extra long leads. That, if you got a junk set of leads, cut the ends off so you still got the banana plugs to plug in the meter. You can make test leads as long as you want to. I usually carry an extra set off of one of the battery testers. That same rules apply. It doesn't matter how long you're going, but all you're doing is sensing at those points, so you can do the same type of test. It doesn't matter what the length is. Someone asked where you purchase the meter kit. You can just call us at the our 1-800 number, or you can send me an email from the link. Go to our website. Any way you'd like, we try to take care of you on that and get one out to you. Where do you get fuses for the multimeter? For the ones we sell, we do carry them. A lot of the other ones, one of the best places I've actually found for like a fluke replacement meter, fuse is Granger. Let's see. Does the manufacturer conduct the calibration? I can tell you X-Tech and Fluke both do calibration. That's one of the reasons we joined up with X-Tech on ours, is because you can send them in and get them calibrated. To me, that's worth a lot. The ones you buy on tool trucks, more often than not, you can send those in for their calibration. Just it does add some extra time delay because of the steps you got to go through, but you can do most of the tool truck ones through the tool truck. Can you calibrate the meter without setting them in? I'm going to say you can check one. If you have the ability to have some accurate pieces that you can check, hey, I know this has a resistance value of X. Check it with your meter, says yes, that did come back in as the same. I put it across a fixed voltage and I know it's still the same. But I would still highly recommend on a multimeter, they get sent in once a year, make sure they are calibrated and certified. Someone's asked if the presentation can be printed from the website. I do not know that. I will follow up and get you an answer to that. But just so everybody knows, you will get an email link to this training, and it will be available so you can watch it anytime. How often would you recommend replacing the batteries? At least once a year. If you use your meter a lot, maybe once every 6 months, but at least once a year. What is considered an accurate meter? Well, there's a lot of people that make good meters. The biggest thing I'm going to tell you, it should not come in a Sunday circular where you get one free with a $20 purchase. You're going to spend at least, $100 for a good meter. You get what you pay for because it's not only, yes, it's a digital meter, but look at the specs and the capacity of them. Again, talking about a lot of meters I've ran across that they're very limited on the range they can safely or accurately read. So a lot of the things that, sensors, whatever you are asked to test, they just don't have the capacity to test them. So you do want to make sure you are doing something good. Forgive me if I'm kind of jumping around. These questions keep coming in, and I'm scrolling and trying to read them as good as I can, as quick as I can. Can you have too much meter or not enough for automotive testing? Yes. Generally, people have a tendency to buy meters one of two ways. They want to spend, $10 to $20 at the discount tool world, or they want to buy the $800 one off the tool truck, so they think they are the coolest kid in town. You want to buy something in a good mid-range that does everything you need to, but do not get caught up in buying something that's got lots of bells and whistles and functions you'll never use. Someone asked if we use oscilloscopes. Yes, we do for certain projects. Most of our guys in the field even carry one that allows them to use their laptop to be oscilloscope. So do we use them? Yes, we do. Is it something I recommend for a shop? No. Use an X-Tech clip-on ammeter. How to display max amperage when I can't physically hold it and load the circuit. I'm not quite sure what you meant by that. I will follow up with you after this and make sure I understand what that question was. Use voltage spike suppressing relays in our systems. Depends what the system is. Yes, there are times we do use the suppressing relays. You're going to test it the same way. The 5-pin relay works the same. The only difference is there will be a diode that's incorporated in that to filter those spikes. But you would test it using the diode function and then just test the relay like you would on the other one. Ask about the link for the recording. Again, it will be emailed to everybody. So anyone that was registered for this will get an email tomorrow with a link for the recording. Just so you know, too, that we do keep those, locked. That means you are required to put in your email address when you watch it. We do that so we can provide fleets attendance reports so we know, not only who watched it today, but in the next several weeks, we can tell who did log in and watch it. Big M versus little m. On the ohmmeter, big M is mega ohm, it's 10 to the 6th power. Little m is milliohms, which is negative. So you're going into thousands of an ohmmeter, or thousands of an ohm. No multimeter can read milliohms. That is something you're going to have to do with either by voltage drop calculations or lab type equipment, but a multimeter will not read milliohms. Did not cover it. Somebody did ask me about the min-max. Meters that do have the min-max function, it allows you to actually recall the highest voltage that the meter saw and also the minimum voltage. So if you're dealing with something that fluctuates, it is very handy that if you're looking at, say 13.1 volts and it drops down because the load was on, or another one popped up, it allows you to look at those minimum max. And if you have more questions on that, feel free to send an email or I'll reach back out to you. Can you download the presentation? Currently, no. Again, it will be available to watch later. Someone asked if we were going to be doing a webinar covering our liftgate charging system. That is what the survey is going to be for. As soon as I close this out, please feel free to ask for any type of training you'd like, whether it's battery testing, battery room procedures, voltage drop testing, whatever. We want to keep doing these, but we want to do what you all would like to see us do. It doesn't do any good if I talk about a subject nobody cares about. So please make sure you do the survey at the end. And I think that's it for questions. If you do have any, again, feel free to use my contact information, send me an email, reach out to us any way you'd like. We're always here to support you. And a lot of you, I see a lot of familiar names on here. I can't wait to see the TMC or some of the events coming up. So thank you all for attending, and please hang on for that survey.